In this first lesson, we're going to talk about points, lines, and planes, kind of the foundation of geometry. Um, and the point, line, and plane are actually referred to as the undefined terms. I like to think of these as the building blocks of geometry, like I said earlier. Um, you got to look at these as they're not definitions of these words, they're just explanations. And then as we go on throughout the rest of geometry, we're going to learn more and more vocab. And these vocab words will be based off of point, line, and plane. We'll get some new vocab words, as you're going to see towards the end of here. Then we can use that vocab to then define more vocab. So it's all a building block. If we don't have point, line, and plane to start, we can't go anywhere. So we'll start off with point. A point is really nothing more than a location, as you see here. I have two examples. Right here I have point A. The little dot here is the point. The little dot here is the point. Now remember, it doesn't have location, but we're going to use the dots to represent the point. Because if you think about this, it has no size. Well, if it really has no size, you wouldn't be able to see it. But for the purposes of being able to see on a sheet of paper or on your screen, we have to use the little dot to represent the point. And then we have a variety of ways to name a point. You can write out the word point and then say whatever its name is. So in this case, point A. We can abbreviate the word point with PT and then put that and then A. Or a lot of times you're just going to see this last one here where you're just going to see a capital letter. And that's going to represent a point. Same thing's going to happen over here with just point B. So what you got to remember about a point is if it's to label it, you're going to use a capital letter. Come back here. Now we can look at a line. Now a line, this is something that's straight. You don't ever have to say straight line, kind of redundant. So if you want to talk about a line, just say line and everybody's going to know that it's straight. But it's made up of points. And a line, similar to a point, is not going to have any thickness or width. Now here I have a line, and notice it has 3 different points on it. It also has this M out here. We're going to use these to name this line. And there's more ways to name a line than there was a point. So we can call this line CE. Notice I've taken the kind of, some would think of it as the first and last point on there. But it really doesn't matter. We could also use point E and D to name the line, and then we'd read it line ED. So, and it doesn't matter, we can change the order on these. Like this first one, if you still want to use C and E, you just don't like the order for whatever reason, you could call it line EC. You could call this one line ED. And when we say that, even though I'm using a different way to name it, it's still talking about the same line. Now notice we have another option here where it just says line M. Notice the M is lowercase, using the label that was up here from the actual diagram. It's kind of the faster way to do it, and you don't have to have 2 letters. And then the even fastest way is just drop the word line and just call it M. If you ever see a lowercase letter, you're going to know that that's a line. Thinking back to a point, if it was uppercase, then it would be representing a point. Lowercase is going to represent a line. And then the last undefined term of geometry would be the plane. This is a flat surface made up of many, many points. A lot of people, when you first start thinking about planes, think about something like the floor or the ceiling. It's a flat surface. Now, obviously, the floor is not going to extend infinitely, but the floor would be a portion of a plane. So when you look at now a picture of a plane, obviously I can't draw something that's going to extend infinitely. So what we do is we just use this parallelogram to represent the plane. Realize it's going to extend forever left, right, in this case up and down. But to show the plane, just use the parallelogram. Again, I have points on it, and then I have this scripted P also, and those are going to help us name the plane. Now when you get to a plane, now you're going to, if you use points to name it, you need 3 of them. And it doesn't matter what 3 points you have, you can pick any 3. So I'm calling this plane FGH, or just putting the points in a different order, I could call it plane GHF. I can also refer to it as plane P. Now not to be confused with point P, notice it's a scripted letter. If this was just a uppercase P, then it would talk about point P, but because it's a scripted letter and we said plane P, we're going to know we're talking about a plane. Now realize if I put more points up here, I can still use these ways to name that plane. Now, those are all of our undefined terms of geometry, and I want you to stick those in your head, point, line, and plane, because they're going to come back over and over again. Now, space, this would be our first defined term. So this is boundless, meaning it goes on forever and ever in all directions. It's three-dimensional set of all points. And I like to think of it, this is where we live. We live in space. Now, don't confuse that with outer space, but the space that we live in. You know, we can reach out forward, we can reach up, down, we can reach in every direction. So we're in that three-dimensional world here. Outer space would be a part of all of space, but don't confuse the two. Now we go on to collinear. I like to look at this word, and in this word I see the word line. So it must have something to do with a line that we talked about earlier, which it does. Now in this one, it's going to be points that are on the same, notice, line, even if the line is not visible. Like here, I have 3 points. When I look at them, they look like they're on the same line, and what I've done just for the purposes of being able to distinguish whether they're on the same line or not, I have a line that actually goes through them. So I can say that these 3 blue points are collinear. Well, then the other side of it would be non-collinear. This would just mean points not all on the same line. And I come down here and I have an example with these 2 pink points. These 2 points, yeah, I could make a line go through them, so these 2 points are collinear. But what happens is, when I introduce this 3rd point, I can't get 1, 2, and 3 points all to be on the same line. So these 3 points together are non-collinear. If I just look at 2 of them, these are collinear, but as a group, all of them are non-collinear. Then you get to coplanar, very similar to collinear, just now you see the word almost in here, plane. So this is just going to talk about points and figures, so really everything that you could put on a plane could be coplanar. And I look at this picture, and these 4 points and this line are all coplanar because they're inside of the parallelogram that represents the plane. And again, on the other side of it, non-coplanar, this would be figures that are not in the same plane. And to show this, now realize that your screen is 2-dimensional. So some students like to think that, well, this kind of side of the plane is going to extend, and eventually it's going to bring that green point in there. But to help us see 3 dimensions on a 2-dimensional screen or a 2-dimensional sheet of paper, we're going to draw it like this. So what you really have to think about is, say this pink plane, think of that kind of as the floor, and then this green point might be a point on your hand above the floor. So we have that green point farther up, and that's how we can show this 3 dimensions on a 2-dimensional sheet of paper. Then you have parallel lines. I'm guessing that many of you have heard of parallel lines. You've talked about them before. This word right here, coplanar, is going to be very important in its definition. So they're coplanar lines that never intersect. Here's a picture of them. I have my 2 lines. Now notice there's these red arrows on them. These red arrows are what are telling us that they're actually parallel. So this is a symbol that you can put on lines to represent parallelism. And then here's just a picture of train tracks. You know that train tracks, as they extend, they're never going to touch. Technically, are they lines? No, because you look up here and they're going to turn eventually. So they're not lines, but we can think of a section of them as being parallel. And we'll move on and talk about just sections of lines in another lesson. And then there's parallel planes, same concept, but now you're working with planes, and these will never intersect. I like to think of the floor and the ceiling, examples of parallel planes. And then our last vocab word for today would be skew lines. Now notice these are non-coplanar, different from parallel lines that cut off the non and would have just said coplanar lines that never intersect. So they're non-coplanar. I'm going to come here to the nut first. Notice gives an example here, kind of this line on the bottom of the nut and this line on the top of the nut. they're never going to touch and they're on different planes. They're referred to as skew lines. Now be careful, because some students will look at this line up here and think that in some cases, you know, they might look like they're on different planes, because you could call this one on the top of the nut and this one on the bottom, or on the bottom of the nut, thinking those are two different planes, and they are, but they also are both on this plane right here. So this line and the bottom line would be parallel, but the examples of the red lines, those are skew lines. If you come over to the cube and you want to think about maybe line DC, extend this forever here, and then you could go with line GB. There would be another example of skew lines. And if you look at where you're located, I'm guessing you're probably in some sort of room. A way I could help you think of finding a pair of skew lines there, just look straight ahead and look at the wall, and then look down to the floor. Where the wall and the floor come together, you essentially have a line there. Now turn to your left and look up the wall to where the ceiling is. Where the ceiling and the wall come together is another line. So those two lines that I just pointed out, there would be an example of skew lines all around you. And that's going to conclude the lesson part. I will also have another video with a few short examples of some things that we learned about in this lesson.